Yeah, good afternoon, students. Good afternoon, one and all. I hope you all can able to see me and hear me, right? Am I visible and audible to all of you? And can you see my screen? If everything is okay, just give me a response in the chat box. We will start the class. Yes, yeah. Thank you so much, JNV, Ramnagar students. Thank you so much. Yeah. So we will continue with hydrocarbons. Okay. So yesterday we have seen the physical properties of alkenes and the preparations of alkenes, right? So today, as I have told you, we are going to see the chemical properties of alkenes. Okay. So there are some chemical reactions which we are going to see here under this. So they are the halogenation reaction, combustion, controlled oxidation, isomerization, aromatization, reaction with steam, and pyrolysis. Okay. So these 7 reactions we are going to see under the chemical properties or chemical reactions of alkenes today. Okay. So if we are able to complete these 7 reactions, then we will move on to alkenes. Okay. So moving on to the first reaction, which is actually called a substitution reaction. Okay, and in that substitution only we are going to see this halogenation. Okay, so the main category is substitution. So in this, halogen is going to get substituted. Got it? So these are the chemical reactions of alkenes. So in the reactant, you have to take an alkene. Okay, so I have taken an alkene for you, and so to this alkane, I'm going to add a group. Okay. If I'm going to add a group, one of the hydrogen from this alkane will be substituted by that group to give the product which you are seeing on the screen. Okay. That group may be anything. Okay. That group may be anything. It can be an atom or it can be some group of atoms. It can be anything. Got it? And if that group is halogen, then the reaction is called as halogenation reaction. Got it? So for the general reaction for halogenation is, we are taking an alkane. We all know that the formula for an alkane is CnH2n plus 2, right? So to this alkane, we are adding the halogen. Okay, X is nothing but the halogen. Halogens are fluorine, chlorine, bromine, and iodines. Okay, so mostly chlorine and bromine will be used. Fluorine and iodine, they are not used due to some reasons. I will tell you those reasons later. Okay, so to an alkane, we are adding an halogen in presence of H nu. In presence of H nu, what is this? This is the light energy, the energy which is coming from the light. Okay, it is nothing but the UV radiation. So this is the condition. So under this condition, we are getting a haloalkane and an HX. Got it? And X, as I have told you, it is the halogen. Got it? So let me give you an example for this reaction. So let me take CH4. Let me take methane as an example for you. Okay. So to this methane, I want to add chlorine. So I want to add chlorine. So in presence of H nu. Got it? Now what will happen here? One of the hydrogen will go out with Cl as HCl. HCl will go out and the remaining is CH3Cl. So what is this? This is chloromethane. So since the haloalkane is derived from methane, the name of the haloalkane is chloromethane. Got it? Like this, you can do various number of reactions. So basically, we are removing the HCl. If halogen is reacting with H nu, HX will be removed to give the haloalkane. Got it? So this is the halogenation reaction, which is the first chemical reaction of alkanes. So is this clear to all of you? Shall we move on to the second reaction of alkane? It's very easy, right? So if you're having any doubt in this, just put it in the chat box. Otherwise, we can move on to the next reaction. Shall we move on to the second reaction of alkanes? Yes? Yes or yes? Okay. Uh, so the second reaction is the combustion. So what is meant by combustion? Combustion is the heating a compound in presence of oxygen is called as combustion. Heating a compound in presence of oxygen is called as combustion. Now we are studying about the alkanes. So alkane is the compound. We are going to heat this alkane in presence of oxygen. Okay, you can see the GIF, right? So wood is burning in presence of oxygen. No, so a substance will get burned in presence of oxygen. So in this combustion, there are two types. One is complete combustion and the other one is incomplete combustion. So what is the difference between two? So that we will see in the upcoming reactions. Okay. First, let me discuss the complete combustion with you. Okay. So on complete combustion of a substance, carbon dioxide molecule will be evolved. Carbon dioxide will be coming out from the reaction if a substance is undergoing complete combustion. Not only carbon dioxide, it is a main substance. It will come out with water. It will come out with water and some amount of heat will also be released. Got it? So if you are getting these three products in your reaction, then you can say that the substance has undergone complete combustion. Okay, let me give you the general reaction for this complete combustion. So you can see the reaction here. Just learn this formula alone. Okay, it is CnH2n plus 2, which is an alkane. An alkane is reacting with 3n plus 1 by 2 moles of oxygen. Okay, it is a ratio to give n moles of carbon dioxide and n plus 1 moles of water. Okay, this is the general reaction. So let us see an example. Let me give you an example. So let me take propane as an example. Okay. So in propane, what will be the value of N in propane? Can anyone tell me the value of N in propane? How many carbons will be there in propane? How many carbons you can see in propane? Yes, very good, Anjanastri. It is 3, right? So what will be the formula for propane? It is C3H8. If C3, if C3H8 is reacting with, so substitute the N value as 3 here. So 3 into 3 becomes 9, 9 plus 1 is 10 and 10 by 2 is 5, right? So C3H8 will react with 5 moles of oxygen to give 3 moles of carbon dioxide plus 3 plus 1 is 4 moles of water. Okay, if you are seeing any reaction like this for propane, then you can straight away select the option without any doubt that it is an example for complete combustion. Okay, so here is the same reaction for you. So propane with 5 moles of oxygen gives 3 moles of carbon dioxide and water. So like this, you can check for methane, ethane, and butane, pentane, etc. Okay, got it? So this is about the complete combustion. Now next I will move on to the incomplete combustion. Okay, so what is incomplete combustion? So when insufficient oxygen is there, when insufficient oxygen is there, then we call that reaction as incomplete combustion. Okay, we are calling that reaction as incomplete combustion. So here in this incomplete combustion reaction, carbon dioxide will not form. Instead of that, carbon black is formed. Carbon black is formed in place of carbon dioxide. Okay, I'll show you an example. I'll show you an example. So here is the example for you. So we are taking a methane and methane is reacting with oxygen. Okay. So now you see it is the incomplete combustion. So how they are telling that it is incomplete combustion? So in the previous slide only I have shown you that if n value is 1, here for methane the n value is 1, right? Then how many moles of oxygen is required if n is equal to 1? The formula says that we need 3n plus 1 by 2 moles of oxygen, right? If you substitute n value as 1, since it is a methane, then the number of moles of oxygen required would be 3 into 1 is 3, 3 plus 1 is 4, and 4 by 2 is 2. So how many moles we require? We need 2 moles of oxygen for methane to undergo complete combustion. But in this reaction, you see we have only 1 mole of oxygen. So the oxygen is insufficient. So that's why we are calling this reaction as incomplete combustion. And from this, we are getting carbon black, which is a solid. Okay, we are getting a carbon black as the product instead of carbon dioxide. Okay, so carbon black that can be used in the printers, ink, and some for pigments and all. You can see that carbon black. Okay, so it is a solid substance. So that is formed. That is formed. So complete combustion is good for environment. So, okay, incomplete combustion leads to a different kind of pollution and diseases. Okay, so this is about the combustion. Now, I hope combustion is clear to all of you. So, all of you just read the general reaction for combustion, okay, for complete combustion. If a compound doesn't fit into that formula, then you can say the given reaction is an example for incomplete combustion. That's it. Got it? So, now with this concept, let us solve one question. Let us solve one question. Yeah. Write the balanced chemical equation for hexane. So write the balanced chemical equation for hexane. So what could be the answer? What is the formula for hexane? What is the formula for hexane? Can anyone let me know the formula for hexane? You tell me the formula for hexane. I will solve the question on the screen for you, because typing the whole equation in the chat box is very difficult, right? So just one of you let me know the formula for hexane. We will proceed. Quickly, quickly. C6, yeah, C6H14. Very good. C6H6, Pradeep. What happened to Pradeep? It is C6H6 is benzene. Okay. Yeah. Very good, Ankita. It is C6H14. Good. So that is a formula for hexane. Now, we know that what we know, alkanes on complete combustion will give carbon dioxide and water. Alkane on complete combustion gives carbon dioxide and water. This we all know. Now substitute the value of N as 6. So if you are substituting the value of N as 6, what you will get? We will get this kind of formula. Okay, 3N plus 1 by 2. N value is 6. So 3 into 6 is 18. 18 plus 1 is 19. 19 by 2 moles of oxygen is reacting with hexane to give N moles of carbon dioxide. That is 6 moles of carbon dioxide and 7 moles of water. Okay. If 2 moles of alkanes, if 2 moles of hexane is reacting, how many moles of oxygen would be required for 2 moles of hexane? So I am going to multiply this hexane by 2. So what I have to do, I have to multiply the whole equation by 2, right? So I will multiply this oxygen also by 2, hexane also by 2. So this carbon dioxide also by 2 and 7H2 also by 2. So what I will get? I will get this kind of formula. So this is for 2 moles of hexane. For 2 moles of hexane, 19 moles of oxygen is required. For 3 moles of hexane, so that 3 into 19 by 2 moles of oxygen is required. Okay, like that you have to find out for different moles of alkanes if they are asking any such questions to you in the exam. Okay, so this is about the combustion reaction. So now let us move on to the third reaction, which is called as controlled oxidation. Combustion is also an example for oxidation only. But we did not control the reaction there. We did not control the combustion there. Okay, it has happened on its own. But here in this third reaction, we are going to do the oxidation only. Oxidation is nothing but the addition of oxygen. Okay, or removal of hydrogen. So here also we are going to add oxygen, but we are going to control the reaction. So how we are going to control the reaction? So what are the steps or what are the ways to control the reaction? So you can increase the pressure, or you can increase the temperature, or you can add some catalyst. Okay, so increasing pressure, increasing the temperature, and adding the catalyst. So using these three ways, you can alter a chemical reaction. Okay, so under this controlled oxidation, I am going to give you 4 reactions. The first reaction is alkane is reacting with oxygen in presence of copper metal as the catalyst. So here the conditions are very important. Reaction condition is very important. The reagents and the temperature and the pressure value which is given above the arrow mark, that is very, very important. Okay. So with copper metal as the catalyst and at 523 Kelvin and at 100 atmospheric pressure, you can see methanol is formed. Methanol is formed. Okay, so methane is giving methanol. So one carbon containing alkane is giving one carbon containing alcohol. Got it? Now coming to the second reaction. So I am taking the same methane and I'm going to add the same oxygen, but now the catalyst is molybdenum oxide. Okay, instead of copper, I am using molybdenum. For this particular catalyst, I am getting aldehyde. You see, it is methanol. Methanol, HCHO. CHO containing compounds are called as aldehydes, right? So it is methanol. One carbon containing alkane is giving the same number of carbon containing aldehyde. Okay. So for copper, we are getting alcohol. For molybdenum, we are getting aldehyde. Got it? Then in the third reaction, you can see here I took an alkane which is ethane. Ethane contains 2 carbons, right? So the same oxygen is added with different moles. But here you can see manganese diacetate is used as a catalyst. So who is the metal here? Manganese is the metal here. For this manganese, we are getting carboxylic acid. RCOOH is carboxylic acid, right? So we are getting carboxylic acid as the product for this reaction. Got it? So 2 carbon containing alkane is giving 2 carbon containing carboxylic acid. Got it? This is the third reaction. Now, in all these reactions, you can see the catalyst is determining the product. Copper is giving alcohol, molybdenum is giving aldehyde, manganese is giving carboxylic acid. Okay. So now the catalyst only determining the product, whether we need alcohol or aldehyde or acid. If I want to prepare acid from ethane, I can use manganese. Okay. If I want to prepare alcohol, I can use copper. Okay. I can use the catalyst which I want to make. Okay. For my desired product. So I am only determining the product by altering the catalyst. Got it? So that's why it is called as controlled oxidation. One more reaction is there under this that I will show. So here is the alkane called 2-methyl propane. Okay. So there is a hydrogen attached to the second carbon. Got it? Now this hydrogen is called as a tertiary hydrogen because it is attached with the tertiary carbon, right? So what is a tertiary carbon? A carbon which is attached to 3 carbon. A carbon which is attached with 3 carbon is called as tertiary carbon. Now you can see this carbon is attached with a 3 carbon. So it is a tertiary carbon, and the hydrogen which is attached to it is called as tertiary hydrogen. Got it? Now to this compound, to this compound which is having tertiary hydrogen, I am going to add KMnO4. So what is the role of KMnO4? It is potassium permanganate, which is a strong oxidizing agent. It is a strong oxidizing agent. So oxidation occurs here. Now this tertiary hydrogen or this tertiary carbon is getting oxidized to tertiary alcohol. This is called as tertiary alcohol. Okay, oxygen is added, no? So it is oxidation. Now the name of this compound is 2-methyl propan 2-ol. So this is the longest chain. This is the parent chain. If I number this chain, to the second carbon, I am having a methyl, and to the second carbon, alcohol is attached. So it is 2-methyl propan 2-ol. Got it? So only tertiary carbons can be oxidized with KMnO4. Okay? If you are taking secondary or primary alkanes, then in that cases and all, you will not get tertiary alcohol. Got it? So this is again the controlled oxidation, and the metal that is being used here is also manganese. Okay, manganese, potassium, permanganate. So all these metals are D block elements. The copper, molybdenum, manganese, all these are D block elements. Okay, mostly D block elements will act as the catalyst. So what is a catalyst actually? The catalyst will alter the rate of the reaction. It will increase the rate of the reaction. Okay, if the reaction is occurring at what to say, if a reaction is occurring after 1 hour, means by using the catalyst I can get the product within 15 to 20 minutes. Okay, so what it is doing, it is increasing the speed of the reaction. That is the role of the catalyst. Okay, so I hope this controlled oxidation is clear to all of you. Am I right? If controlled oxidation is clear to all of you, just give a thumbs up, or yeah, thank you Ankita for your quick response. Fine. Now next we will move on to the fourth reaction, that is isomerization. Okay, isomerization. So what is an isomer? Compounds having same molecular formula but different structures, that is called as an isomerization, right? That is called as isomers. Now we are seeing the reactions of alkanes. So in the reactant, let me take an alkane, let me take hexane. Hexane contains 6 carbon, right? So this is an alkane. Now to this alkane, what am I doing? I'm going to add anhydrous AlCl3 with HCl. Anhydrous AlCl3 and HCl. So this is very, very important. Okay, the reagent which we are using in the reaction, that only determines the product. Okay, so if you are using this anhydrous AlCl3 with HCl, you will end up with two compounds. One is 2-methylpentane and the other one is 3-methylpentane. So all the three compounds which you are seeing on the screen, they are having the same molecular formula, but the structures are different. Okay, that's why this reaction is called as, yeah, very good Ankita, same chemical formula but different structure. So that's why the name of this reaction is isomerization. Okay, so coming to the next reaction, that is aromatization. Aromatization. So from the name itself, it is clear, right? So an aromatic compound is going to get formed from an alkane. Okay. First, let me give you the general reaction for you. Then I will discuss with an example. So here is a general equation. So an alkane is taken first. To the alkane, 773 Kelvin heat is supplied. That is very important. It is very high temperature, okay? And 10 to 20 atmospheric pressure is used. Either you have to use chromium oxide or vanadium pentoxide or molybdenum trioxide. You have to use any one of these three catalysts. Okay, you should not use all the three. Any one of these three should be used. Okay, now this is the reaction condition. Under this reaction condition, dehydrogenation, that is removal of hydrogen, occurs and cyclization of the product will be formed. So benzene will be formed and its homologous, okay, will be formed. So let us see with an example. So again, I have taken hexane. The name of this compound is hexane, right? I have written the hexane in a kind of cyclic structure. Just I have just tilted. That's all. The compound is hexane. It contains 6 carbon. So what you do? Take this alkane and put it in 773 Kelvin and 10 to 20 atmospheric pressure, or give these pressure and temperature, and use one of these catalysts. So the 6 carbon containing alkane is now going to form a 6 carbon containing benzene. Okay. So the 3 moles of hydrogen, 3 moles of hydrogen will go out. That's why it is called as dehydrogenation reaction. Got it? So now let me ask you one question from this. Instead of hexane, if I am using heptane, as the reactant, what will be the product? What will be the name of the product? Can anyone try for it? If I am taking heptane instead of hexane, what I will get? Try for it. Can anyone give me the answer for this? Hexane with 773, heptane with 773 Kelvin and at 10 to 20 atmospheric pressure with the same catalyst. Has anyone? It's very easy. Just try for it. Don't scared of giving the answer, okay? Don't think that your answer will be wrong. It can be wrong. Let it be wrong. No issues. Okay, we are not going to do anything. We are all studying, right? So don't hesitate or don't get scared. Just try for something and put it in the chat box. We will discuss in the class. Don't think that ma'am will scold me if I am giving the wrong answer. Don't think that way. Okay, we are all studying. So you don't have to worry. Dibenzene. Okay. So, okay, we'll discuss. We will discuss. C7H8. C7H8. Okay, C7H dibenzene. Dibenzene will not be the product. We will discuss. Don't worry, student, the one who gave the dibenzene answer, that is actually not the product. We will discuss. C7H8. One of you gave C7H8, right? I think it is Shivashankar. So, what is the name of that C7H8? Can you give me the name of C7H8? What is the name of C7H8? Okay. C7H8 is the correct answer. Now I will discuss with you. Okay. So, heptane, toluene. Ankita, you are right. Very good. Toluene is the answer. So, we are going to take a 7, toluene. Good. So, let us discuss that. So, let me take the 7 carbon containing alkane. Okay. So, this is the 7 carbon containing alkane. 1, 2, 3, 4, 5, 6, 7, which is heptane. This is called as heptane. So now under this reaction condition, so the 6 carbon will form the benzene ring, okay, which is the phenyl ring. And now the terminal carbon, so that will also be converted to CH3. It is already CH3, right? So it is CH3. And plus 3H2 is coming out. So the formula is C7H8 and the name of this compound is toluene. Very good. Okay. If octane is taken as the alkane, we will end up with ethyl benzene. So this toluene is otherwise called as methyl benzene. If octane is taken as the reactant, we will get ethyl benzene. Got it? So the 6 carbon will form the aromatic ring and the remaining number of carbons will be in the branch. Got it? That is the concept. So this is how you will get questions, okay, from these parts. So they will, from organic reaction part, how will you get question means reactant, product and reagent. Okay, a reactant is there, product is there. And here the reagent is used, okay. Either they will give you the reactant and product and they will ask you to find out the reagent. This is one type of question. Otherwise, they will give reactant and reagent and you have to find out the product. This is another type of question. So in many reactions, a reactant will not straight away give the product. It will undergo some intermediates. That intermediate will be asked. Okay, suppose if A is getting converted into X, okay, on reacting with this R, this X will be converted to B. So it is a two-step reaction, right? Now this X is the intermediate. They will ask you this intermediate. So this type of question will be asked. Okay, they will not ask you to find out the reactant. Okay, they will not ask you to find out the reactant. Either you have to find out the product or the reagent or the intermediate. So these 3 type of questions you can expect from the chemical reactions and from all the organic chemistry part. Okay. So we can move on to the 6th reaction, right? So I hope aromatization is clear to all of you. Let us move on to the reaction with steam. Yeah, reaction with steam. Steam is nothing but H2O in gaseous state, right? So let me take an alkane, methane for you. And now this methane is going to react with water in the gaseous state, okay? In presence of a catalyst. And now the catalyst is nickel, okay? And at high temperature, I am going to heat this two component with the nickel. And finally, I'm going to get carbon monoxide and 3 moles of hydrogen as the product. Okay. This is the method which is used for the industrial preparation of hydrogen gas. Because you see, for 1 mole, for one cycle of this reaction, 3 moles of hydrogen is produced. Okay. For 2 cycle, if you are doing the reaction for 2 times, you will get 6 moles of hydrogen, right? So more number of hydrogen can be produced from this reaction. So in the industries where they are preparing this hydrogen gas, so they are following this particular reaction to prepare the hydrogen. So we can get hydrogen from any reaction, but this particular reaction is used in the industries, okay? So this is about the reaction with steam. Now coming to the last reaction for today, for alkanes, it is pyrolysis. So what is pyrolysis? The higher alkanes means more than 7 carbon containing alkanes or more than 5 carbon containing alkanes, they will be heated up. Okay, they will be heated up to a very high temperature. So on heating the alkane to very high temperature, they get decomposed. They get decomposed to the simpler lower alkanes. Okay, breaking down. They will be breaking down into very simpler alkanes, and that reaction is called as pyrolysis. So you can see higher alkanes on heating at a high temperature decompose into lower alkanes and alkenes, etc. Okay, so let us see an example with the same hexane. So I am taking the same hexane as the reactant for this reaction also. Okay, now this hexane can be broken down into 3 different ways. If I am heating this hexane to 773 Kelvin, the same temperature which we have used in aromatization, okay? So this hexane can be broken down into 3 different ways. So one is, it is giving C6H12 and H2. Okay, so what is this? This is hexene, 6 carbon containing alkene. So hexene and hydrogen. The second way is, it is giving butene, 4 carbon containing alkene, no? So it is butene, and this is ethane. It is ethane, okay? And the third way of breaking down is C3H6. This is propene and this is propane. So all alkanes will have CnH2n plus 2 as formula, right? So the same way, all alkenes will have CnH2n as the formula. So that we will discuss in the next slide, okay, about alkenes. So this kind of breaking down is happening in the hexane. So in hexane, we can see 6 carbons are arranged in the linear fashion. So we are having carbon-carbon bond as well as carbon-hydrogen bond, as well as carbon-hydrogen bond in it. Okay. So in many cases, this carbon-carbon bond, so this carbon-carbon bond will be broken down. So in case of the second combination, you see 4 carbon is going out as one product and 2 carbon is coming out. So this 4 and 2, so this bond is broken down to give the second combination. Okay. In the same way, different carbon-carbon bond is breaking down to give the lower alkenes and alkenes. So this reaction is called as pyrolysis. Scientists are saying that this pyrolysis of alkanes is believed to be a free radical reaction. It is a free radical. Free radical means it is an intermediate, right? A carbon which carries the single electron is called as free radical reaction. So that is believed for this pyrolysis. Got it? So this is about the 7th reaction. All the 7 reactions of alkenes is discussed to you. Let me summarize. Okay, the 7 reaction. So under the chemical properties, the first is halogenation. So this was the general reaction we took there, and we have prepared haloalkane. And under combustion, there were two types. One is complete and another one is incomplete. Incomplete, I gave you one formula, right? Just study that. And coming to the third reaction, it is controlled oxidation. In that, three different catalysts were used. For copper, we got alcohol. For molybdenum, we got aldehyde. And for manganese, we got carboxylic acid. And the fourth reaction is isomerization. And for isomerization, we used anhydrous AlCl3 and HCl as the reagent. Okay. And for aromatization, 773 Kelvin with 10 to 20 atmospheric pressure and with one of the chromium oxide, molybdenum oxide as the catalyst. Then for reaction with the steam, we used nickel metal as the catalyst and then on strong heating. And for pyrolysis, just heat the alkane to 773 Kelvin. That's all. Okay. So this is about the 7 chemical reactions of alkanes. Okay. With this, the alkanes topic of this lesson is getting over. So next I have to move on to the second topic of this lesson, that is alkenes. So do any of you have any doubt from the alkanes part? Not only from chemical reactions, from physical properties and from the nomenclature, isomerism, from the introduction. So from all those, the whole alkane, if you're having any doubt, you can ask me. If you're not having any doubt, just put it in the chat box that it is clear to all of you. I will move on to alkenes. I will move on to alkenes. Shall I move on to alkenes, students? Yes. Yes. Want me to explain controlled oxidation? Okay. Yeah. This is the controlled oxidation. So controlled oxidation means oxidation is occurring with the knowledge of the person who is doing that reaction. Means the person is controlling the reaction by altering the catalyst, by changing the temperature and changing the pressure. Okay. So now here, if copper metal is used as the catalyst, the corresponding guy is getting alcohol as the product. If molybdenum is used, aldehyde is the product. If manganese is used, carboxylic acid is the product. So the catalyst is determining the product. Catalyst is determining the product. Who is giving the catalyst? The person is giving the catalyst to the reaction. Okay, so the person is controlling the reaction, and in all these reactions, addition of oxygen is happening to alkanes. So that's why it is called as controlled oxidation. Clear? Please explain isomerism. Isomerism? Which isomerism? You're asking that chain isomerism and those things? That part? Yes. Okay. Okay, just a second. Just a second. In which combustion carbon monoxide will not form in any of the combustion. Only carbon black is formed. Okay, carbon black is formed in incomplete combustion. Okay, and carbon monoxide they do form in some reactions, but not with alkanes. If it is forming, it will be the product of incomplete combustion only. Okay, it will be the product of incomplete combustion because carbon monoxide is a poisonous gas, right? Only if a substance doesn't get combusted properly, such kind of poisonous gas will be formed. Otherwise, carbon monoxide only forms. Okay. So now I hope the screen is visible to all of you, especially for the person who has asked this doubt, right? Is the screen visible? Yeah, yeah. Okay, no issues, no issues. Now, fine. So, talking about the isomerism, isomers are basically the compounds which have same molecular formula but different carbon skeleton. Yes, okay, but different carbon skeleton. Alkanes generally show the chain isomerism. Alkanes generally show the chain isomerism. So, what are chain isomers? Compounds having same molecular formula but different carbon skeleton are called as chain. Basically, isomerism means they will have same molecular formula and they will have different structure. Specifically talking about chain isomerism, they will have different carbon skeleton. So the two examples, two isomer of a particular compound is given to you. So the example is C4H10, which is actually the butane. So for this butane, I can draw two isomers. And those two structures, you can see it on the screen. So you see one is butane. Let me write the condensed structure for you. CH3, CH2, CH2, CH3. So this is N-butane. And if I want to draw the isomer of this, that is 2-methylpropane, the structure will be, condensed structure will be like this. CH, CH3 and CH3. Okay, this is 2-methylpropane. So to the second carbon, a methyl group is attached, right? So it is called as 2-methylpropane, which is nothing but the isobutane. Now these two compounds are having N-butane and 2-methylpropane. These two compounds are having the same molecular formula, but when you see the carbon skeleton, here all the carbons are arranged in a linear fashion, whereas in the second compound, only 3 carbons are in the linear straight chain manner. One is in the branched position. Okay. Sorry for the background noise that you're getting from these dogs. Sorry for it. Okay. So this is the isomerism. So this is straight chain carbon and this is the branched chain compound. Got it? Carbon skeleton is differing, but the molecular formula remains same. So this chain isomerism is existing in the alkanes. Okay. And also with the same example, I gave one more this pentane example also, right? C5H12. For C5H12, these 3 different isomers were possible. One is in the straight chain, and the second compound we have 1 branch, and in the third compound we have 2 branches, 2-methyl. These 2-methyl you can see. So they are the isomers. Is the isomerism part clear to the person who has asked this doubt? Yes? Shall I move on with the alkenes? Yes? Okay. Yeah. Yeah. Just give me a second. Okay. Yeah. Now it's ready. Fine. Yeah, all of you can able to see the screen, right? Alkenes. Yeah, we'll start with alkenes. So the learning objectives under alkenes are the introduction again, the same nomenclature and isomerism, and the preparation of alkenes. Okay, I thought of completing these topics today, but I don't think I will complete. Okay, we are left with only few more minutes. So let us see the introduction part, and I will try to cover the nomenclature if time permits. Okay. So moving on to the introduction of alkenes. Alkenes are basically the unsaturated open chain hydrocarbons. Alkanes are saturated, alkenes are unsaturated. So they will have carbon-carbon double bond. Okay, and is also known as olefins. Alkanes were called as paraffins, right? So here alkenes are called as olefins. Why it is called as olefins? Because they are the oil forming compounds. They are the oil forming compounds. That's why it is called as olefins. Okay. So it is an unsaturated compound, and it is also known as olefins. So these two are the points that you're getting from this introductory part of the first slide. And coming to the third point, the first stable member of alkene is ethene. It is ethene of formula C2H4. C2H4. So the general formula for alkene is CnH2n. It is also called as olefin because they are the oil forming compounds. Alkenes are the oil forming compounds. Okay. So this is the general formula for an alkene. Okay. General formula for an alkene, and if n value is equal to 1, you will end up with C1H2, right? So this compound is called as methylene. This compound is called as methylene. This methylene is a unstable species. Why it is called as unstable? Because it is a short-lived species. It is a short-lived species. So that doesn't exist. So it is unstable. Then if n is equal to 2, what we will get? We will get C2H4, right? So this C2H4 is called as ethene since it has 2 carbons in it. So C2H4 structure is there to you on the screen. Now, the hybridization of the 2 double bonded carbons, they are sp2. That is sp2. In alkanes, what is the hybridization of the carbon? It is sp3, right? So here the hybridization is sp2. So let me show you the orbital overlapping. So in this double bond, one is sigma and the other one is pi. And here carbon, hydrogen, they are sigma bonds. So totally around one carbon, we have 3 sigma bond and 1 pi bond. You all know that sigma bond is formed by the head-on overlap of the orbitals, and pi bonds are formed by the sideways overlap of the orbitals, right? So let me show you the orbitals. So here are the sp2 hybridized, 3 sp2 hybridized orbitals of each carbon, and one unhybridized p orbital. One unhybridized p orbital of each carbon is shown to you. Now, the hybridized orbitals are now going to form the sigma bond. So how many sigma bond will form? This will form the bond, and this will form the bond with hydrogen, and this will form the bond with hydrogen. So in the same way, the second carbon also will form the bond with hydrogen. So C2H4, right? So these are the sigma orbitals, sigma bonds. And the pi bond is formed by the overlapping of the unhybridized sideways, unhybridized p orbital, sideways overlapping. Got it? So you will end up with this kind of structure. So in this structure, you can, in this picture, you can see the bonding clearly. So these are the 3 sigma bonds of each carbon, and this is the pi bond, head-on and sideways overlapping. Got it? Now coming to the structure of double bond in alkenes, I want to tell you some more information about it. I hope the structure picture which I have shown you is clear to all of you, right? If it is not clear, just ask me. I will show you again. So now, just give me 2 more minutes. I will finish the class. Okay. Now this consists of one strong sigma carbon-carbon sigma bond, which I have already told you, which is formed by the head-on overlapping of the sp2 hybridized orbital, and the bond energy, bond enthalpy value, you see, it is 397. Okay, sigma bond is having 397 kilojoule per mole. The energy required to break the bond is called as bond energy. So that value is 397. You have to supply this much of energy to break that bond. And one pi bond was there, and that pi bond is weak. So that's why the bond energy is very, very less. Yeah, Aisha, I'll show you the slide. Okay, let me complete this and I will show you. Don't worry. Okay. So the bond energy for the pi bond is 284. You just see it is less. It is less than the sigma bond. So now, if the bond energy is very less, then it shows that we can break the bond so easily. Since the bond is weak, since the pi bond is weak, we can break the bond so easily. Now, which bond is strong? Sigma bond is always stronger than pi bond. Okay. And this alkenes, since they contain pi bonds, they are more reactive than alkanes. They are more reactive. Alkenes are more reactive than alkanes because of the presence of pi bond. Why they are more reactive? We can break the bond easily and we can do the reaction so easily in the pi bond. So that's why they are more reactive. Got it? So this is about the structure of the alkene. Now tomorrow I will discuss the nomenclature of alkene. Okay? Okay, now I'll show the previous slide for Aisha. If any of you have any doubt in this, just let me know in the chat box. Otherwise, you can leave the class and get ready for the next class. Okay, thank you students for listening the class today. So we will meet on Monday, okay, with the class. Aisha, can you able to see? Did you take the screenshot? Yes. Okay then. So everything is clear, right? Yeah. Yeah. Okay. Thank you. Thank you. Thank you so much, students. Take care. Bye-bye.